Today we're going to be looking at learning target 2E, solving and graphing a linear inequality. The first thing you need to do is set up your notes so that you have all of the key pieces of information that you're going to need during the lesson and that you'll want for class tomorrow. Make sure that you've titled them 2E and that you have dashed versus solid line, shading in slope-intercept form, shading in standard form, and then all four of the examples that we'll be looking for when checking your notes. Go ahead and pause the video as you set this up, and then hit play when you're ready to see the next slide. Just a reminder that solving and graphing a linear inequality is much like graphing linear equations like we have done before. Okay, you've seen this stuff before. It's not brand new, the graphing piece. The solving, the shading piece will be new. In terms of graphing in slope-intercept form, remember we have our intercept, so in this case, if it's y equals 3x plus 1, our y-intercept is 1, and our slope is 3, so we go up 3 to the right 1. And we can graph our line between those 2 points. In standard form, 3y minus 2x equals negative 12, we can graph this by saying negative 2 times what number gives us negative 12, so negative 2 times 6 makes negative 12. So our x-intercept is 6, 0. And then 3y equals negative 12. So 3 times negative 4 makes negative 12. So our y-intercept is 0, negative 4. Once we get our two intercepts, we can graph them and draw our line through those 2 points. Graphing these linear inequalities are very similar to this, so know that you will use these skills throughout the course of this learning target. First thing you have to know when graphing a linear inequality is whether you're using a dashed line or a solid line. We use a dashed line to represent that the points on the line are not solutions to our linear inequality. We use this dashed line whenever we have less than or greater than, either strictly less than or strictly greater than. A solid line means that the points on our line are solutions to our linear inequality, and we include those. We use that for less than or equal to, or greater than or equal to. Either of those two symbols tells us that we're going to be using a solid line when graphing our linear inequality. When we shade in slope-intercept form, the two most important things for you guys to know is that you are looking at when it's greater than or equal to, it means we shade above. So in the first example here, it's greater than or equal to, so we shaded above the line. And here, the third example, it's strictly greater than, so we shaded above the line. Now when it was greater than or equal to, it was a solid line, just as a reminder. And when it was simply greater than, it was a dashed line. When it's less than or equal to, it means that you shade below. So here it's less than or equal to, meaning it's a solid line, and it is shaded below. Here it is less than or equal to again, so it's a solid line, and we shade below the graph as well. Now we can also use a test point, and we will talk about that here in just a minute, and I'll show you a few examples on that. When we shade in standard form, we can use the same principles that apply in terms of less than or greater than, and less than or equal to, greater than or equal to, as we do with slope-intercept form. The other way we can do it is by using a test point. The test point that we recommend you use is the point 0, 0. You can plug that in. If, when you plug in that point, you get an answer that is a true statement, you shade on the side of 0, 0. If you get a false statement, you shade away from the side that contains 0, 0. We'll demonstrate this so you guys can kind of pick up on it. For example 1, we have the equation, or the inequality, y is greater than negative 2/3 x plus 5. So our slope is negative 2 over 3, our y-intercept is 0, 5. Our symbol tells us 1, that we will shade above, and 2, that it is a dashed line, because it's not or equal to. So we start at 5, we go down 2, right 3, down 2, right 3. We can follow this pattern, and we have our line that is a dashed line, and then we shade above the dashed line to check. Now, we talked about test points and how those can be used. The test point, if we pick, is 0, 0. So we plug in 0 for y and 0 for x. Well, that gives us 0 is greater than 0 plus 5. So when we simplify, we get 0 is greater than 5, meaning that we have a false statement. So 0, 0 is below the line, which is false, so we shade above the line because we know that those points would make our inequality true. Similarly, and easier, is just to know what your symbols tell you in shade, above or below. That'll be a little bit quicker for you guys. In example 2, we have the inequality y is less than or equal to 2x minus 7. Here, our y-intercept is negative 7, and our slope is 2, so we go up 2 over 1, up 2 over 1, to get multiple points along our line. Now, because it is or equal to, we know it's going to be a solid line, and because it's less than or equal to, we know we're going to shade below. So we shade below our line that portion of the graph. Now, you can tell that it is also false just by looking at our work down here when we plug in our test point of 0, 0 to check and see if it works. Here, it does not work. It gives us a false statement of 0 is less than or equal to negative 7, so we don't shade on the side of 0, 0. There is a case where if 0, 0 falls on our line, if it actually is on our line, we do not use the point 0, 0, we find a different point. That's a pretty rare occurrence, and typically you can either use 1, 1, negative 1, negative 1, negative 1, 1, or one of those points around there to use. The only time you don't use 0, 0 is when it falls on the line that you are graphing. Example 3 is an example in standard form. Okay, so here we're looking to find our intercepts. So if we look for our x-intercept, we know it's 8 because 3 times 8 makes 24, and 4 times 6 makes 24, so our y-intercept is 0, 6. So we graph those 2 points, over 8 up 0, and over 0 up 6. We know it's going to be a solid line because it is greater than or equal to, and it also tells us that we're going to shade above the line. You can take a look at our work with a test point. 3 times 0 plus 4 times 0, those are both zeros. 0 is greater than or equal to 24, which is false, so instead of shading below the line where 0, 0 is, we shade above the line where we know it will be true. Our last example is another standard form example where we have negative 2x plus 5y is less than 20. Here, we know it's going to be a dashed line because it's strictly less than. So we have our dashed line graphed through our x and y-intercepts, our x-intercept being negative 10, 0, and our y-intercept being the point 0, 4. And since it's less than, we know we're going to shade below the line. Now the way we can check ourselves is if we plug in our test point, negative 2 times 0 plus 5 times 0, those are both zeros, and we get the inequality 0 is less than 20, which is true, so we shaded on the side of the graph that contains the point 0, 0. Make sure you have these notes and be ready to practice the skill in class tomorrow. Other than that, bring questions to class that we will answer for you and get you ready for our test. Good luck, guys.